Howdy, y'all. I think I'm live. One of these days, I'm actually going to figure out how to, tech. So it looks like, yeah, I think I'm live. All right. So, howdy, everyone. Howdy, Judy and Peter. Both of you are in the chat. So glad to see you. As anyone who knows me knows, this stream is obviously random in terms of I decided to do this about an hour and a half ago. My sleep schedule is all over the place, so I actually got up and started working somewhere around midnight. It is now 3 in the morning. And so, yeah, I just figured since I hadn't streamed in a while, I might as well stream. So, yeah. Here, let me see if I can do this. I want to be able to look at the chat. Okay. So, all right. So what I'm going to do today? Well, what I'm going to talk about today, I'm going to try to focus on two things specifically. One is this notion of attempting to use physics to prove the existence of a creator. And more specifically, it was a conversation that was prompted by Austin Whitsitt, who he has a standing invitation that if he wants to have a conversation with me one-on-one, he is more than welcome to reach out and we can schedule that. I first encountered this notion. Apparently he's doing the rounds with this argument. I noticed this on Earth Awakenings, and it was him, myself, PhD Tony, and Melodic, and it was very chaotic. Essentially, it seemed as if there were three of us ganging up on Austin. I wasn't really getting a word in edgewise, or at least I felt that I didn't. So I decided to step out, and before I left, I offered him that invitation. So I want to sleep. What is that? Yeah, exactly, Judy. So I decided that I would. I've been thinking about his argument, or at least the broad strokes of it, and since then, and so yeah, I'm going to share my thoughts on that to a certain extent. The other thing that I wanted to talk about, and hopefully I can get it up and running in short order, is there was this video that was recommended by a friend of the channel, Eric E. It is a video made by Dr. Jason Lisle, whose book on astronomy, Taking Back Astronomy, I have and have read some of. I've even written notes in the margin in some cases. I've mentioned this book in the past because I fundamentally disagree with its main, or the philosophy of it. The philosophy that, not the whole God part, the whole, you have to approach science with a worldview, that you must approach science in a biased way. I fundamentally oppose this, or fundamentally reject this notion. I believe it is diametrically opposed to what one should do as a scientist, meaning that one should come at a scientific endeavor as unbiased as humanly possible. However, he puts forth the argument that in order to properly understand the cosmos, and in order to properly understand really the world around us and a physical nature, you have to accept God and the Bible as the absolute truth. In terms of Bible literalism, I honestly don't know what his stance on that is. I don't exactly think that because I believe, never heard him say this or mention this. It may be in there. Excuse me. He does not go with the chronological 6,000 years old. He goes with some number of 10,000 years old, but I don't know how that number is determined. The only biblical age I have ever heard how it was determined was around 6,000 years, and that is based on the the book of begets, the chronology of Adam onward. So I don't know how he feels about Bible literalism in the traditional sense of the Bible should be taken absolutely literally. Anyway, he came up with this video talking about results from JWST. I didn't quite catch the date, but given some of the topics that he mentions, or some of the discoveries that were mentioned, I believe this video was fairly new. Specifically, he talks about a spiral galaxy that was found in the early universe, which is wholly unexpected. So I want to kind of kibitz that video a little bit. To be honest with you, I haven't watched the entire thing in its entirety. It is, I think, an hour and some odd minutes long, and I honestly don't have the patience to listen to that sort of misinformation for any extended period of time, so I kind of skipped around. Excuse me. I'm still getting over this cold that I had a couple weeks ago. Just still a little bit of congestion that I need to get rid of. Anyway, I am not going to try to steelman Witzett's argument because I don't remember it too well. But the gist of it is he is attempting to use a logical argument about time to insist that there must be a creator. I believe the dichotomy, or I believe the choice, can't remember the particular D word, but the choice is either time has a beginning or it's eternal. I know PhD Tony rejects that. I don't believe he rejects the fact that you have a binary choice. Apparently, according to him, there is an intermediate choice. He attempted to explain it to me, and I grasped what he was saying, but I did not. Effectively, he was talking about the notion of an unbounded surface, like the skin of a balloon. The skin of a balloon is finite, but is boundless. So you have something that is finite in amount, therefore it doesn't quite have it's not eternal, as it were. So typically this argument is used to explain the expansion of the universe in space, in spatial coordinates. But he suggested looking at it through a temporal coordinate system. And so time itself has a finite value. It is not infinite in quantity, it is finite, but it is boundless, meaning one can traverse the dimension of time and never hit a wall. And presumably that would also mean you would never have a t equals 0, I suppose. Although, again, I haven't quite thought about it too much. But in any case, Witzett puts forth this argument that, well, I think he's parodying someone else's argument. And he's putting forth this argument that either time has a beginning or time is eternal. And what I don't remember is he has an argument to suggest that it has a beginning, that time is not eternal. And I believe he suggested that the Big Bang Theory, for example, suggests that time has a beginning. Tony has a specific example or cosmology in mind, which I, again, don't remember, talking something, that refutes this. I pointed out two different cosmologies, theoretical cosmologies, that also reject this notion. Penrose's CCC cosmology, or conformal something cosmology, has time as eternal. It is but it is a Big Bang cosmology in that it starts off small, gets infinitely large, which somehow turns into infinitely small, and it just repeats over and over again. Loop quantum gravity, from my understanding, is also eternal. There is no t equals 0. The universe that did not look like anything, does not resemble what it is today, collapsed down to a very small but finite volume and then expanded outward into the universe today. It's different from the Big Bang, Big Crunch, because the pre-existing universe did not or does not look like the universe that we have today. And that universe is, from my understanding of the theory, does not have a beginning. But anyway, so I'm willing to entertain this sort of notion for his argument, mainly to get across the point that, as I've always emphasized with the Big Bang Theory, we don't know if time has a beginning. Science cannot answer that question. That question is still very much open. Because we cannot reconcile relativity and quantum mechanics as of yet, we do not know what the conditions were like at the time of the Big Bang. We can mathematically describe it as a singularity. However, that is not sufficient for me and for a lot of my colleagues. In simply having a mathematical description does not necessitate that that is what is physically happening at that point. So, as I've many times have mentioned, we don't know if there is actually a finite point or beginning to the universe. As it happens, I don't think there is. But as I mentioned to him, and I think it was Taylor actually, this is my worldview. This is my bias, is that I want the universe to be eternal and having a cyclic form, because that is what I see in nature. I see that the processes in nature are almost predominantly cyclic. So why should not the universe follow that example? But that is my worldview. That is what I want the universe to be, not what I think the universe actually is. I don't know what the universe actually is or does, or, because we don't have the data to support any sort of, we don't have the evidence. We don't have the data to provide evidence to support any one particular theory over the other. All we know right now is that the evidence is overwhelmingly telling us that the universe is expanding from some small position or some small spatial scale. That's it. How it will end, that's also another open question. But young Earth creationists, people like Matt Powell and all that, will rail against cosmology, or have railed against Big Bang cosmology, because they believe it is, it violates the second law of thermodynamics. Oh yeah, that was what he was talking about. Apparently Whitsitt was attempting to use the second law of thermodynamics as a law that requires the universe to have a beginning, because an eternal universe, entropy could not continually continually increase. I haven't thought enough about that to make an estimate on that. But people like Matt Powell, Ken Hovind have suggested that Big Bang cosmology is inconsistent with physical law because it suggests something from nothing. Now it seems that folks like Whitsitt are attempting to use Big Bang cosmology as actually a proof of God. I believe Jason Lisle is one of these people as well. He looks at the Big Bang cosmology and say, obviously there is a point or a point of creation. I will say that I think Lisle is doing that. No, I'm going to back that out. He does not believe in the Big Bang cosmology, as hopefully we will see in the video. Which brings me finally to my point. And this is a point that I've made many, many times over, is that the question of proving God using physics/logic is impossible. One cannot use physics or logic to prove God. because God is an infinite concept. There are infinite being. He transcends the physical nature of the universe. He is both physical and not. God is infinite in his wisdom, is infinite in his being, is infinite in his understanding. Physics is by nature imperfect. We understand things, we can describe things as well as we understand the circumstances of that thing. So, for example, if I wanted to absolutely predict the gas molecules in this room, I would need to know absolutely what the acceleration due to gravity is at every single point in this room. I would need to know what the pressure is or density of the material in every single part of this room. I would need to know what the temperature was in every single part of this room. That's not something I can know. I can make measurements of those things. I can make broad assumptions of those things, but I can't know those infinitesimally small regions of the space, those characteristics. I cannot know them. And the other thing is there may be other factors that I am completely ignoring, such as this fan is going to affect the conditions of the motions of particles in this room. It's going to cause the particles near the fan to move more so than if the fan were not there. The fan's in my computer. So I would need to be able to characterize how those fans are affecting the motions. When it comes down to when you want to know the absolute description of reality, it becomes extraordinarily complex. Because not only are you talking about having to know effectively infinite precision, because we are talking about an absolute definition of the physical situation, or an absolute description of the physical situation. You need infinite precision, which we cannot obtain. You also need to have a complete understanding of all of the physics that are happening in here. You need to identify all of the variables, and you need to identify the physical processes which depend on those variables, which we do not know. And I would contend that we cannot know all of those. But we certainly do not know them. So physics by its very nature is imperfect. Logic is a human invention. Logic is something that humans have developed over the years. Now, I am not well versed in logic, and yes, I'm sure I've forgotten his name. Woody? Yeah, the dude that I used to talk to. I'm sure that's gonna be clipped. He's gonna love that statement, and people are gonna clip it. I know very little about logic, and when I'm talking about logic, I'm talking about the field of study of logic, of rhetorical arguments, that sort of thing. So, like laws of identity or whatever define rules of logic. I know very, very little about them because I don't use them in science. I don't know of too many of my colleagues who actually use the rigid definitions of logic in their fields or in their work. And I think I know enough about logic to realize that there is no single laws of logic. There are schools of thought. There are schools of logical thought within a greater subfield. And if you have schools of thought within logic, that basically tells me that logic is not universal across the board. So again, if we're going to talk about logic, and I guess you have to ask the question, which logic are you talking about? But I'm getting into a territory where I honestly am talking out of my ass. Again, I don't know much about logic. But what I do know is that because it is a human invention, it cannot, by its very nature, describe an infinite or perfect being. Something that is imperfect cannot be used to describe a perfect being. Therefore, whatever it is that which it thinks he has, is ultimately flawed, because neither physics nor logic are equipped to be able to prove the existence of God. Because in order to prove the existence of God, you have to somehow actually use those things to understand the very nature or some part or nature of God, which again, I don't think they can. Or at least I have never seen anything close to a compelling argument as to how to in any way describe the nature of God using either of those two disciplines. They're not supposed to do that. Or I don't know, maybe logic is. Physics is not supposed to do that. Physics is only dealing with the physical realm. God is, as I said, is a part of the physical realm, but is ultimately a metaphysical being. So therefore, physics really has nothing to say on the subject of any sort of deity, any sort of metaphysical question, or any sort of metaphysical entity, being, quantity, whatever. So, again, it's an interesting thought experiment. And that's why I'm intrigued by it, particularly with this notion that Tony had come up with, or that had suggested to me that instead of thinking of space as a finite, unboundless, or boundless quantity, we can think of time in the same way, which follows from my understanding of relativity, is that time is simply another dimension. You have spatial coordinates and then you have the temporal coordinate, but effectively they're all the same in terms of their intrinsic properties, aside from the fact that time can only flow in one direction. You can never have a negative time, as it were. There is past, but that is different from negative. Different from negative time, I suppose. Actually, I don't know. Again, these are interesting questions to me, and I don't know enough about the subject to answer such nuanced sort of questions about time or about relativity. But I do believe that that Tony is on something, that time can be thought of in the same way as space. But that's really all I had to kind of say about that subject. Again, I'm pretty much repeating myself from other streams, but this notion of using physics or logic to prove the existence of God is wrong-headed. One, it cannot be done by the very nature of things, and two, it to me is antithetical to the teachings of Christ, because to me proof belies. If you have proof, you have no need of faith. And faith is a cornerstone of Christianity. He asks us to have faith. He asks us to put faith in him he asks us to put faith in his teachings, that they are the correct ones. And without that, I think the entirety of the point of Christianity is missed. That if you are doing this because you know that God exists, and you are doing this because you know that these laws are going to get you some kind of eternal reward, then you're not doing it for the right reason. You have to have faith that what you are doing is going to actually have the outcome you want it to have. For myself, I have to have faith that being a pacifist, being someone who does not believe that violence is good in any form whatsoever, that war is ultimately destructive and amoral. Even the whole hypothetical, if there were loved ones in front of me and I could the only way that I could save their life was to do violence. My answer to that question, one, I don't accept that scenario, but if that is the scenario that I'm in, then, I will, they will have, I will have to, they will have to die, effectively. I would not do violence to save their life. And I know that probably makes me look weak or whatever. I'm sure I will be judged on that one, but I do not believe that violence is correct in any way, form. There is no justification for violence as a moral good at all. I have to have faith that view is ultimately for the betterment of all people. In that scenario, I would hope that if my loved ones were taken from me because I chose not to defend them using violence, that God would take care of them. I have faith that God would not judge them harshly, and that God would love them for the rest of eternity. That is my faith. And I must have that faith, because if it were proven to me that that action is the right one, then I have ultimately no choice unless I am insane. Because obviously I would choose the right one. I would choose the course that was correct, because that is rational. I would have to be insane to deliberately go against my own self-interest. So, and if I don't have choice, then I don't have free will. And that, to me, is the most central point of Christianity, is having the free will to sin, having the free will to do whatever it is you want to do in mind, body, and soul. As I've said before, if someone can definitively prove to me that free will does not exist, that is the only way that I would deny the existence of any kind of divine entity. Faith is not blind belief. Judy, I completely agree with that. I have my faith. I have the faith of nonviolence or whatever, of being a peacemaker, of loving both my neighbor and my enemy, of not only sitting with sinners but washing their feet to honor them and to relieve their suffering. I have this because I've looked into it. I have read the Bible. I have read theological texts, and it resonates within me. These are things that I believe are good. These are things that I believe are what my personal relationship with God, the divine, would have me do. But all of that is predicated on faith, not proof. And for those out there who are concerning themselves with trying to prove God to atheists, what are you really trying to do, and why? Is that really, because ultimately, to me, the goal is to bring about the kingdom of Christ on earth. That is ultimately our purpose. That is my purpose, is to do what I can to do that. Trying to prove the existence of God to other people does not seem to achieve that goal in my eyes. Howdy, Victoria. You are Victoria, apparently. I would much rather, in conversations with atheists or non-believers, Muslims, Jews, whoever, people who do not believe in God or do not believe in the ways of Christ, I would much rather have conversations as to what constitutes a moral good, and to share experiences of how taking those moral actions have made me feel closer to the divine. I would love to have those types of conversations. It's difficult to have those kind of conversations with atheists because they don't have faith to begin with. That is a non-judgmental statement. That is simply a statement of fact. They do not believe in a divine being, so therefore there is no shared experience. There is no frame of reference from which to have these conversations. Well, maybe. Whether or not something is a moral good, I definitely believe you could have a conversation with an atheist about what constitutes a moral good. So, as to, I mean, you would have to do it in the outside the context of divine teaching, but, you know, whatever. I'm just kind of rambling at this point. But yeah, this insistence by evangelicals to always need to prove the existence of God. And on top of that, and this segues into Dr. Lisle, is to somehow use the book, the Bible, as some kind of science textbook. To use the Bible as some sort of proof, again, of God's existence. That, oh, look, science has demonstrated that the things that are said in the Bible are accurate, are true. So therefore the Bible is true, therefore God is true. I would love for people to have the same experience with God that I do. Absolutely would love that. But ultimately, that is not what I want to have other people do. What I would like for people to do is to treat each other with love and to try to prove to them that the Bible is a science textbook does not achieve that aim, in my opinion. Because all that does is it basically says, hey, the Bible is true. And then you get into the question of what does the Bible actually teach? And then you get into Bible literalism, which is, I do not know how you take the Bible literally and use it as a coherent moral textbook. Because, yeah, God has commanded the wholesale slaughter of people. I don't know how that reconciles with blessed be the peacemakers. Those two things seem to be extremely contradictory, two extremely contradictory statements. But maybe I can have them. That's also a conversation that I might be able to have with an evangelical. But again, trying to use science to prove the existence of God to me is not useful. And it's also, wrong-headed. Because the Bible, for as great a book that it is, in my opinion, obviously, it's not a science textbook. It doesn't even come close to being a science textbook. The story of creation, and I do ultimately want to create a book about, or create a video about this, the story as laid out by Genesis does not fit with scientific evidence. The ordering of events is not correct. But I want to look into that. I want to be able to do that in a thoughtful and explicit sort of, or a, what's the word I'm looking for? Not explicit, not expedient. Man, I'm losing my words all over the place. Methodical way. I want to take it point by point and provide evidence as to why it is wrong based on the evidence that we currently have from a scientific standpoint. So, Peter, that's fine. If a God doesn't enter into my thinking, I take my own responsibility. And I am all in favor of that. I think that one of the things that is often overlooked, particularly who are left-leaning politically, is that we all need to take responsibility for our actions and the energy that we put into the world. And yes, I'm going to sound a little new agey with that. What we do, how we hold ourselves, how we go about our daily lives, we all need to be responsible for how we do that and for the act or for the repercussions of that, because no act is without consequence. and we must all take responsibility for that consequence. Either we accept the consequence and we're okay with it, and we continue to act in the way that we do, or we don't. And we attempt to change our behavior such that the consequences are within our ability to accept. All right, let me, Windows 11, Christ. Let me bring this up. This was in a conversation with Eric. There it is. Pause that. Let me go over here. Pause this. Let me window capture.
All right, well, it's good to be with you.
Let me pause that. Window. Jason Lisle. Okay. Let's do this. Let me go down here. Let you be in front. On bottom. I know this is very exciting. Oh, all right. I could do it this way. Look at me being all techie and savvy and shit. Nope, that's not what I wanted to do. Oh, my arch nemesis, Neil deGrasse Tyson, who probably will never know that I exist. And I am oddly okay with that. Pull this out of here. Just getting things to my own liking. All right. Aha, now I can see. Now I can see. Oops. That's not what I wanted to do. This. Aha. Okay. Excuse me. All right. So. Oops. That's not what I want. Oops. Me thinking that I was all techie and stuff. Apparently, not really. Okay. All right. Is that right? Is that right? Okay, I can see the chat. I can see the video. I can see me in the video. All right. Like I said, I have not watched this entire thing. It's an hour and a half, and I have to admit, and I have to say that for better or for worse, I do not have the patience to listen to this sort of material for any length of time. I get irrationally angry by it because I think it is not only wrong, it is harmfully wrong to both the notion of science and the notion of Christianity and God. So, but we will go with this. Jason Lisle. Jason Lisle is actually a part of Answers in Genesis, which is an organization of scientists who they are science communicators, but through the lens of that God exists and that God must exist in order for this science to make sense. Dr. Lisle, I have his book. I'm not going to go get it, but it's back there. It's Taking Back Astronomy. I've talked about him before. His notion of the speed of light seems to have changed, or at least his notion of look-back time seems to have evolved, because it is no longer what he states in that book. In that book, he basically states God made it look that way. So Now he has some other notion that I had not fully looked into yet. But here, apparently, he is speaking to a group of people at the Denver Society of Creation, and he is going to be highlighting some observations of that were done with the JWST, which not only does he say refutes the cosmological model, the Big Bang cosmological model, but also supports the notion that God exists. So, first thing I'm going to do, well, first off, let me play the video, and you guys can tell me if you can hear it, see it, all that kind of good stuff.
And I do get to talk about the James Webb Space Telescope, this marvelous new instrument that we have, paid for by your tax dollars. So thank you very much for your contribution to this instrument. It's helping to confirm creation, and so that's a great use of tax dollars.
Okay, so I'll wait. If someone in the chat could tell me, or in the chat could tell me whether or not you could hear that, if the volume was good, what have you. I suspect that it's quieter than me because I'm loud. While I get an answer on that, I am going to say that there it is. He claims that the James Webb telescope actually proves the existence of creation. It doesn't. Actually, the observations of JWST, volume's a little low, the observations of JWST are in fact problematic to the notion of creationism, particularly young Earth creationists. All right, hold on. Audio settings. Settings. Audio. This is not what I want. Where is the button that I normally have? Is this frozen? Nope. All right. Forgive me for a moment. I am trying to fix the volume issue. I think I'm getting there. Nope, that's not what I wanted. Okay. Let's try this. I've made myself a little softer or a little less loud. Actually, I'll just move this over here.
So that's what it looks like. That's the James Webb Space Telescope. So it is out in space. It's 1 million miles out in space, and taking these wonderful images of very distant galaxies. And I want to bring some of those results to you tonight and how they confirm creation, as well as some brand new research. You'll be the first group to hear it. Other than there's a group of students I spoke to up in Washington State. They heard it a little bit before you, but you'll be the second group to hear it.
I don't know what he's talking about in terms of new what have you, or new discoveries, but I suspect that what he has something of his own I think I do know what he's talking about later on, but he has a different view. Apparently he has his own cosmology as to explaining a young Earth vast universe. Yes, I would agree with you. Technically, if science could prove or disprove God, God wouldn't be supernatural, which he very much is. All right, so I'm going to go over here. See what this looks like at 1.5 speed.
Brand new research that's about to be published. It's been peer reviewed, so I feel okay talking about it now. And I want to begin
Peer
talking
reviewed.
about the history of the spacecraft and its predecessor, the Hubble Space Telescope, because most people are familiar with the Hubble Space Telescope and some of the remarkable images that it's delivered. You can Google any image in astronomy, and you'll get the best ones are Hubble, right? So that's the Hubble, and that was launched back in 1990. The James Webb was being planned even before that as the successor to Hubble, and it is a successor to Hubble in point, so it's a non-Keplerian orbit. It's kind of interesting. But
I wanted to point this out because I think he kind of just talks about the two various instruments of Hubble and JWST and what they can observe, what parts of the electromagnetic spectrum they can observe, which I'm sure he is correct on whatever it is on those descriptions, because that has nothing to do with God. That, you know, those are true regardless of whether or not you believe God or God is a thing or not. So I will accept that he is giving proper adequate descriptions of this. What I wanted to do here is JWST is an interesting device to me, or an interesting telescope to me, for a variety of different reasons, but one of them is where it's located. Hubble, the difference between Hubble and one of the differences between Hubble and JWST is that Hubble is in orbit around the Earth. And so there are times when the sun gets in the way. And so it has certain limitations simply based on the orbit that it's in. JWST has with JWST you no longer really have that because of its location. It is located around what we call the second Lagrange point. Now, I'm not going to try to describe to you the gravitational dynamics of what the Lagrange points correspond to, but all I will say is, based on the Earth, Moon, Sun system, the gravitational fields of those three bodies taken into account, really the Moon is actually is negligible in this calculation. There are 5 points where you have what is known as a quasi-static equilibrium, meaning that if you put an object in that location and you did not apply a force to that object, any force at all, anywhere, then that object would remain stationary to the sun and the earth for all time. So the chances that there is no force acting upon an object in those particular locations is obviously not true. Simply because of radiation pressure, the forces on those places is going to be non-zero. But to explain those points are points where if you were to just drop a telescope at any of those points, and that telescope no longer experienced any force other than the gravitational fields that it was in. It did not experience an acceleration, I should say. Apart from the gravitational fields that it was in, it would stay in that location relative to the two other bodies. And what JWST actually does is that it actually orbits the L2 position, which is marvelously cool. The other thing I want to point out with L2 is that because of the success of JWST, NASA has basically said, you know what? That's the new hip place to put satellites. So from my understanding, a number of Nancy Roman, the new telescope that hopefully the administration will not cut, even though it is 95% finished. And yes, they are thinking of scrapping a project that has under budget and on time and is 95% complete. This is a multi-million-dollar project anyway, I'm not going to go there. But when Nancy Roman gets launched, I believe it is going to the L2 position because of all the advantages to it. And it is, yes, millions of kilometers away from the Earth. So the bad thing is with Hubble, when we realized Hubble was nearsighted, we sent a shuttle mission and corrected it. With James Webb, knock on wood, if anything should go wrong with James Webb, we're kind of up creek. There's nothing we can do to fix it. When it fails, it fails, and there's no way to repair it in any way. Anything sent out there would not. Is this related to a hill sphere? Um, hills, in a way, a hill sphere is basically the. Let's see. If you are within, I should know this. um, if you are within the hill sphere, then you will not. So if I'm looking at a planet, if a planet is within, if gas and dust is within the hill sphere of a, you know what? I'm not going to speculate on it. Judy, I will come back to you on that. I don't want to. I don't want to say anything inaccurate with that. Um, it has to do with the ability for a body to gravitationally collect or collapse next to another gravitational body. So I will say that I am at the moment uh, ignorant of that. I will refresh my memory on it, and I will definitely get back to you on that. Here we go.
Star, and that would be called population 1. It's kind of backwards. Population 3 is the first generation, population 2 is the second, population 1 is the third. And we see population 1 and 2 stars all around us and in the distant universe. We've never seen a population 3 star.
Correct.
Interesting. But
so what he's talking about there is that astronomers very broadly put stars into theoretically 3 categories. And they are based, roughly speaking, on their age. More specifically, they are based on their what we call metallicity. Chemists love astronomers because, to us, there are only 3 types of material in the universe. There's hydrogen, there is helium, and there are metals. So, the periodic table, hydrogen and helium, metals. Oxygen, metal. Fluoride, metal. Xenon, that's a metal. We don't care. This is how much that astronomers in general actually care about chemistry. I in jest, there obviously chemistry is of particular importance when it comes to interstellar material, planetary geology, and all that. But when we talk about metallicity, really what we're talking about is a fraction of heavy elements to hydrogen. And typically we use the proxy iron. So when we talk about the metallicity of something, we give a number to the metallicity. When we quantify the metallicity, what we're talking about is the ratio of, or rather the logarithm of the ratio of iron atoms to hydrogen atoms. And we have separated these into 3 populations. You have your population 1 or POP1 stars. These are the newest stars. These are the ones with the highest metallicity. To understand that, very quickly you have to know that with the current cosmology, we believe that hydrogen and helium were the only, hydrogen 75%, helium roughly 25%, and then a very, very small fraction was isotopes of those 2 elements and lithium, maybe a little bit of beryllium. All of the other elements, all of the heavier elements that make up you, me, this coffee cup, the coffee within inside the coffee cup, all of that was made within stars. So when the Big Bang happened and when material was first formed, those 4 elements and their isotopes were the only things that were formed from the Big Bang itself. Everything else was created through the processes of star formation, star evolution, and then star death. And so you have this first population of stars. It makes a certain fraction of heavy elements. Those heavy elements then go into creating the next population of stars. Those elements aren't destroyed. They are added to. And so you get a higher population, like the amount of lead in the universe as a fraction goes up. The amount of hydrogen goes down. So lighter elements over cosmic time, then the fraction of lighter elements to heavier elements drops because of stellar action. Population 1 stars, young. very young. They are within the galaxy. They're basically within the spiral disk of the Milky Way galaxy. Population 2 stars. These are older stars. These are typically orange, yellowy stars. And they are of low metallicity. Those can be found within the bulge, along with some Pop 1s. The galactic center, you find population 2 and population 1 stars, but on the outer spherical portion of the Milky Way galaxy, in the globular clusters and so forth, those are all almost exclusively population 2. Population 3 would be the very first stars, which we know very little about because up until this point, we have no observations of them. These stars would be the stars that were formed in first after a couple 100 million years, or million years after t equals 0. These would be immense. These are theoretically going to be extremely massive, extremely luminous, and extremely short-lived. We're talking less than a million years from start to finish. Whereas the Earth, or the Sun, for example, is on the order of billions of years old. These would be the ones that created the first heavy elements in the universe, heavier than beryllium and lithium. So, no. So that's what he's talking about.
These farthest galaxies would have to be made, the earliest galaxies would have to be made of population 3 stars, because the heavy elements.
Incorrect. So this is this is something that I found which shocks me, which absolutely shocks me with this gentleman, is that he is doing what flat earthers are doing. He is going to make a claim about the model that is wrong. He is going to claim that the heliocentric model, or the Big Bang cosmology, claims that the first galaxy, or the first generation of galaxies, should be made of population 3 stars. That is not what our models say. The first generation of galaxies are meant to have the galaxy came after the star. Seems pretty self-explanatory. You have a galaxy, it is made up of stars. You have to make up the parts before you can make up the whole. And as I said, population 3 stars are extremely, or again, theoretically, are supposed to be extremely short-lived. So these population 3 stars are not expected to form into galaxies within the cosmology. Now, I could be wrong about that, but that is not what I was taught, and that is not what that is not the impression that I get from from the papers that I'm reading. This notion that early galaxies should be composed entirely of population 3 stars, that is incorrect. So he is using a flat Earth methodology.
It's not informed yet, right? Okay, so you got the secular predictions. Fewer galaxies at great distance, they should taper out because you're looking back in time.
Oh, he is making
lithium. So you got, on the periodic table, you got hydrogen, helium, lithium.
So, secular predictions of JWST. These aren't the secular predictions of JWST. This is well, first off, let me say this. Because these are not the predictions. Well, I'll get into that. What he means to say is, or what he should say, is that these are the scientific predictions by JWST. As I have said repeatedly, science does not have a religious bias, either for or against. Science is neither Christ-like, nor is it or anti-theist. It simply is. It has nothing to say about religion. So calling them secular predictions simply indicates to me that this gentleman has a bias in his things. Now, so let's look at these predictions, and I will let you know to the best of my knowledge, whether or not he is actually correct about these things. He states the first prediction is fewer galaxies at great distances. Yes, to a certain point. So the Big Bang cosmology believes that there is at some point a cliff, as you were, where prior to the formation of galaxies. And so during that time, and so basically you have the Dark Ages. You have essentially nothing. You have no large scale structure at all. And then you had the formation of the first stars. They go bang. They create the first population 2 stars. Those population 2 stars, due to the presence of dark matter, will begin to form the earliest galaxies. So yes, for a very short period of time, there are expected to be very few galaxies at high redshift. Redshift is a way of determining both time and distance, time and distance, with the understanding that the speed of light is invariable, that the speed itself does not change, regardless. The speed of light within vacuum does not change regardless of location or time. Then, if something appears to be 8 billion light years away, that tells us that we are looking at it as that galaxy was 8 billion years ago. So that is how astronomers essentially look back in time, or time travelers, as it were, where we are seeing the further out we look, the younger and younger the universe is. And so this is actually correct. At larger distances, we would expect to see fewer galaxies. Up to a certain point, again. 2, the furthest earliest galaxies should be low mass, clumpy, and irregular. Yes, that is also something that is expected, because essentially it takes time for the dark matter to bring all of the baryonic matter together to build up a large or high mass galaxy. They are also expected to be irregular because the number density of galaxies in that location is going to be high. And because of that, you're going to have gravitational effects. There is a phenomenon that is known, and I love calling it this. It's called galactic cannibalism. If you think about the distance between stars and their physical sizes, if you take that ratio is so immense. How immense is it? It is so immense that the chances of one star gravitationally interacting with another star are very, very, very low. Not impossible, but very, very, very low. Now, if you take this same analysis or same approach, and you approach it when you place star with galaxy, the distance between galaxies and their relative sizes, this ratio is significantly lower, to the point that we expect gravitational interactions between 2 galaxies to be fairly common. More so in the early universe, because the early universe, the size of the universe was literally smaller. And so that ratio was dropped even lower. As the universe expands, that ratio of distance to relative size of the galaxies, or the distance relative to the size of the galaxy, that ratio is going to go up. In the early universe, galaxies were all expected to be gravitationally interfered with. And when you have some kind of gravitational interaction between 2 galaxies, that causes those galaxies to rip each other apart, or at least one galaxy is ripped apart. But the shapes of those galaxies become irregular, because this is not a uniform process. It is a complex process that, if you want to understand properly, really requires the use of supercomputers. And then finally, he says the farthest galaxies have no heavy elements, only pop 3 stars. This is not correct. Again, as I've stated, the earliest galaxies should be very early pop 2 stars. the notion that the first stars, population 3 stars, these would have been born and died prior to the formation of the first galaxies.
Everything else is a heavy element in astronomy, okay? And there's a reason for that. In the Big Bang view, the Big Bang is supposed to, the universe pops into existence, it's very hot, there's the energy is, the temperature is essentially infinite, and then as it cools, eventually the temperature drops to where atoms can form, and given the density and
so he says that the energy within the universe is essentially infinite. I would need a citation for that, because that is, it really depends on what he means by the term essentially. The amount of energy within the universe is finite. Therefore, it is not infinite. So when you say essentially infinite, what he's saying is it's really, really big. And in that case, in that sense, yes, he is correct. The mass energy budget of the universe is immense. I don't know what it is off the top of my head, but it is very, very large. Is it infinite? No. Is it close to being infinite? Depends on who you ask. I would say no. Infinite is pretty big. Is way bigger than even the biggest of numbers. So this to me is, again, misunderstanding of Big Bang cosmology.
temperature at that time, the only atoms that should form in the Big Bang are hydrogen, helium, and lithium, the 3 lightest
And a little bit of beryllium.
elements. The Big Bang cannot produce any heavier elements. But we got heavier elements in the universe, right? We're made of a lot of them. We're made of stuff like oxygen and carbon, and we should be grateful for that. But the Big Bang can't produce that. So how do you get the heavy stuff? In the secular view, the first stars form from hydrogen, helium, lithium, and then in their core, the massive stars, the ones that are really massive, in their core, when they run out of hydrogen, they start fusing these other elements, and eventually they explode.
All of them are massive. All of the first stars are expected to be massive. All of them are expected to fuse all the way up until iron, at which point iron is effectively the end of the road. You cannot gain energy from either splitting it through fusion or slamming them together through fusion. So you have an iron core. Basically, you have no way to create any more energy through nuclear reaction. The gravitational pressure of the outer envelope collapses in it upon itself with such speed that a supernova results. And in this case, because the cores of those stars are so massive, how massive are they? They are so massive, they are going to form into black holes as opposed to neutron stars.
And so stars produce the heavier elements, and then when they explode, blow them into space. And so if you've heard Carl Sagan say we're all made of stardust or we're all made of star stuff, that's what he means. In the secular view, heavy elements are produced in the cores of stars. Now that being the case, the first stars that formed, what would they be made of? Only hydrogen, helium, and lithium, because the other stuff hasn't formed yet. Now when the most massive of those stars explodes and produces the heavier elements and spreads those into space, the next generation of stars can collect a little bit of the heavy elements, and so they'll have a little bit more metals, what we call metals. And those would be called population 2 stars. And then the third generation, and our sun is supposed to be a third generation star, they would have the most metals. And the sun has quite a lot of metals for a star, and that would be called population 1. It's kind of backwards. Population 3 is the first generation, population 2 is the second, population 1 is the third. And we see population 1 and 2.
Astronomers like to do things backwards. Our magnitude system is also backwards. The lower the magnitude number, the brighter the object is.
Stars all around us and in the distant universe. We've never seen a population 3 star. Interesting.
That is correct. We have never seen a population 3 star because those are expected to have formed the very earliest stages of the universe. They are expected to have, as I've said, formed prior to the first galaxies. Now, while these things are extremely massive and extremely luminous, they're not that luminous. Or are they? I might get into that later.
But these farthest galaxies would have to be made, the earliest galaxies would have to be made of population 3 stars, because the heavy elements hadn't formed yet, right? Okay, so you got the secular predictions. Fewer galaxies at great distance, they should taper out, because you're looking back in time. And there shouldn't be any beyond a redshift of 14, because that corresponds to a time of only 300 million years after the Big Bang. It's not enough time for galaxies to form, according to the simulations.
Correct.
And the ones that you do see that are close to that distance ought to be irregular, low mass, baby galaxies, and they should have only population 3 stars. Now, it occurred to me, I want to make some predictions too, because I don't believe any of that nonsense. So I'm a biblical creationist.
He doesn't believe any of that nonsense. He doesn't believe any of the things that are supported by evidence or are theorized due to physics that we have created from evidence.
And so I don't believe that I don't necessarily believe you're looking back in time. That's a talk for another night. But in any case, I would expect to see lots of galaxies at great distance, even beyond redshift 14, because I don't believe in the Big Bang, and I don't believe galaxies formed. I believe they were spoken into existence by God, and I don't see any reason why he would stop at a redshift.
I'd like to know where in the Bible it states that galaxies were formed. Stars, yes. Galaxies, not mentioned.
To 14. So I would expect there would be galaxies going way beyond that, and they have about the same density as nearby galaxies. Furthermore, since I don't believe that galaxies have evolved over billions of years, on account of I don't believe in the billions of years, I would expect that the farthest galaxies would be just like nearby galaxies, fully formed, massive, and well-structured galaxies, just like nearby. I don't believe in baby galaxies. Now, galaxies come in a range of sizes, right? There's dwarf galaxies and there's massive. Ours is pretty big. Ours is on the upper end. But I don't expect that looking farther out in space, you'd see smaller galaxies, because I don't think they've gained mass over billions of years, because I don't believe in billions of years. Furthermore, I expect those farthest galaxies will have heavy elements, because I don't believe in a Big Bang that produced just hydrogen, helium, and lithium. I know from the Bible that the heavy elements were already around before the stars formed. How do I know that? Because in Genesis 1, 1 and 2, God made the heaven and the earth. The earth was without form and void. Darkness was on the face of the deep. Spirit of God was hovering over the water. H2O, O is oxygen. Oxygen existed on day 1. Stars were made on day 4. Which is first, oxygen or stars? Oxygen, yeah. So the heavy elements are...
Well, there's one thing that I'll be going over in my video that illustrates that the account of Genesis is scientifically inaccurate. We have seen the sun is in fact older than the Earth. We have seen stars that are also older than both the sun. So and our theory of how the Earth came into being is now is well supported by evidence, and is getting even more supported by evidence when we see the same sorts of things happening with exoplanets. We are now getting to the point where we can start to, I saw a press release about a paper that has said that they have detected the first protoplanet. They have actually been able to image a Jupiter mass planet in the process of formation. And it is doing so just as the modified Nice theory has suggested, or at least it is doing so within the confines of that theory. So we have scientific evidence, which he would have to refute each and every point of that. That tells us that the Earth is in fact younger than the sun. The Earth was not in fact called into being, and then the sun was created 2 days later.
It already existed. And so I don't see why there should be a generation of stars that didn't have any. So you can see why, how I'm motivated biblically to draw these conclusions. And you'll notice that these...
No, you're motivated not because of the Bible. You're motivated because of your own personal bias. And I don't know why. And I would love to know why. Why is it that you need the Bible to be literal in order for you to have faith? I don't understand that.
These are basically the exact opposite of what the secularists are concluding, right? They think galaxies stop at redshift 14. I say they keep going. They think the farthest galaxies will be babies, low mass. I think they'll be high mass, well structured. They think the farthest galaxies will have no heavy elements. I think they will have heavy elements. Exact opposite. And because I have confidence in the Bible, I was confident enough that their predictions would be wrong and mine would be right, that I also tried to predict how the secularists would respond when their predictions fail. Okay? And you can read about this. I've got it online. This was my prediction. Secularists will respond to their failed predictions. They won't give up the Big Bang, because then they'd have to admit creation, right? So what they'll do is they'll just try to push the galaxy.
No. So that is also false. If the Big Bang Theory is ever dropped, is ever forgotten or discarded or what have you, the other option isn't creationism. That is a false dichotomy. If it is not, if Big Bang, then not creation. If Big Bang, or if not Big Bang, then creation. That's not how this works. If it's not Big Bang, then there can be some other mechanism, which is not creationism, that explains the observations. And he's correct in this. When we saw these observations, and SE Montreal is very keen to have pointing these out to me, that one of the first observations of JWST seemed to contradict the principles of, or the predictions of the Big Bang. Effectively, there were galaxies that appeared to be far more massive than would be predicted at that stage of evolution. So he quotes, Webb discovers galaxies formed much earlier than previously thought. Yeah, that's essentially a headline off of one of the, I would imagine that is the headline off of one of the first science communication articles that came out after this discovery. Yeah, that's, yes. Why would you not think this? So you're saying that we should, because of this one piece of evidence, we should throw out all other pieces of evidence and accept biblical cosmology as being accurate, despite obvious pieces of evidence, or excuse me, pieces of evidence that are obviously contradictory to the Genesis story, as I just said. Okay.
Galaxy formation back even further. They'll say Webb discovers that galaxies formed much earlier than previously thought.
Okay.
Yes.
Yourself into a corner, so now galaxies have to form faster and faster and faster.
Yeah.
No, we have not painted ourselves into a corner. We have a understanding of the, we have a theory of how the universe came into being. And now we have evidence that seems to contradict or seems to not be consistent with those predictions, or at least a prediction of that Big Bang. So now we have to reevaluate those predictions. Those predictions stem from how we believe physical processes evolve backwards through time. Specifically, things like how stars form, how quickly stars form, how quickly stars form, in what proportions do stars form, meaning for every 10 solar mass object, how many 1 solar mass objects form. That changing that ratio, changing that function will change the amount of mass that gets formed over the same amount of time. If you form more massive stars in the same amount of time, your galaxy is going to be more massive than if you had predicted otherwise. The amount of dark matter also could be wrong. Our understanding of how much dark matter there was and how it was distributed may also be wrong. So our predictions are not set in stone. Scientific predictions are not carved into granite. Each of those predictions is based on an understanding of how physics would occur at that time of the universe based on our current understanding of what it is today. We could be wrong. These predictions could be wrong. When it comes to falsification of a theory, that theory, we start looking at whether or not that theory is falsified, whether or not those predictions, whether or not that the observation is completely outside the range of allowable predictions within the Big Bang. And so far, we have not exhausted the ideas behind the Big Bang. This is not painting us into a corner, because, again, there's this notion that there is this absolute one answer, that science predicts one answer. And if that one answer is wrong, then our understanding of the entire concept is wrong. That is not how science operates. And Dr. Lisle should know that.
Yeah. So, but that's their problem. And you can read these predictions on the website, biblicalscienceinstitute.com. I wrote that January 21st, 2022. That was before James Webb had taken any data. It had just been launched. And I thought I better get on the ball and make these predictions before it actually observes anything. It wasn't until July of 2022 that we got the first data back of these distant galaxies. And so what did it find? Did it look out through distance where you can see just only a few galaxies and then they kind of stop? This is what it saw. Yeah. Amazing. And again, you're not looking at a star field. Each one of
So before I get into this, I want to try to steelman his position in terms of biblical cosmology as seen through the eyes of Dr. Lisle. I could be wrong in this, but I'm going through context clues of what I have just heard. Effectively, what he believes is that the universe was created by a divine being at the size at which it is created now, which is no larger than, I guess, I don't know. It's created at a certain size, and that it is static. that it is steady state. Effectively, he is a person who I believe would be someone who is in favor of the steady state model, at least in some form or another. He does not believe the universe is expanding. So ultimately, all of his predictions are based on this model. And so the stars that we see around us are the same stars that are everywhere in the universe. Because he does, as he stated, he does not believe that galaxies evolve, meaning that he does not believe that stars go through a cycle of a cyclic process of being born, fusing elements into heavier elements, dying, spreading those elements out into the ISM through various mechanisms, those elements then collapsing back into each other to form more enriched more metal-rich stars, and that process is ongoing. He does not seem to believe that that is happening. So therefore, all of the stars in the entire universe must look like the stars that we see today. The population of stars around, or the population of galaxies, must also be constant throughout all cosmic history. And so, as he stated, he does not expect that the galaxies to be few in number at the earliest stages. He does not believe them to be low mass or irregular, because he believes them to essentially look the same way that the galaxies look like today. So let's get into this. And he's going to talk about this image. He basically says all of these objects are galaxies. Because I am that guy, I will say that that is actually not the case. There are at least 2 objects in this image that are in fact stars. Those are the ones with the pointy things on them. Those are diffraction spikes. So the big honking thing with the little spikies, that's a star within our own galaxy. The one on the lower right is also a star within our own galaxy. All the rest of them, yeah, those are galaxies. And a lot of them, and you can see that there are many different types of colors. There are blue galaxies and there are red galaxies. And typically what that's going to indicate is the age, or rather age and or stellar formation rate of a galaxy. Red galaxies are typically what we call red and dead. These are elliptical galaxies. These are older. The higher population stars, the higher mass stars have died off. And you're just left with the low mass stuff that lives trillions of years. Blue galaxies, or bluer galaxies, are galaxies where star formation is in the process of occurring. So new stars are actively being born even as I ramble through this video. I'm going to skip ahead. To
success. And 2022 was a very fun year to be a biblical creationist. It really was. Because we got to see these come in and watch the secularists squirm a little bit. That's always fun.
Squirm. I like how he refers to having our observations or having our predictions to be shown to be inaccurate as us squirming, as if we needed those predictions to be correct in order to put forward or continue with some sort of evil agenda. No, actually, many scientists have been on record as saying they are very excited about these results because they challenge the predictions that have been made. Because now we got a whole new set of evidence to play with. Now the theorists can twiddle the knobs on their models to make it work. And that's fun, apparently. So we're not squirming. If anything, we're really happy as a whole. These observations are showing what they are. Now I'm going to go back. I just really want to quickly state something like something this. He states that the JWST observations have shown that there are heavy elements in those galaxies. That is correct. The metallicity of these galaxies, we have yet to find a ratio of iron to hydrogen in any of these galaxies to be 0. Now, so there are no POP3 stars, but as I have already stated, that was not expected. We did not expect galaxies to be made up of population 3 stars. If there are population 3 stars, that would in fact have been something new and novel. And actually, that would have been a huge find, because we would have actually found the very first generation of stars. He claims that these farthest galaxies have population in 1 and 2 stars. I have not seen this claim. I have actually never, of the papers that I've looked at that talk about the farthest galaxies, they don't mention population. They mention metallicity specifically. They mention that these are extremely poor, metal poor galaxies, which is in accordance to prediction. They are predicted to be very low metallicity, as has been already explained. So, in the essence of time, I'm going to skip for. Actually, no. Let's see what he has to say.
Keeping score, the secularists were predicting fewer galaxies at great distances and none beyond redshift 14. That's wrong. We were predicting that many galaxies at great distances exceeding redshift 14, and that's correct. Some out to redshift of 20, based on these, at least the preliminary findings. Secularists were expecting the farthest galaxies would be low mass and clumpy baby galaxies. That's wrong. We predicted that the farthest galaxies would be fully designed and mature. That's correct. We were seeing spiral and elliptical galaxies at these distances.
Okay. Let's go back to this.
Stretched out like that. In fact, some of these are the same galaxy. I think that one and that one are the same galaxy. It's just 2 different images. One's gone around. The light's gone around this nearby galaxy, one way, one the other way. So you get 2 images.
He's talking about gravitational
lensing. Some of the galaxies in there, but it's really spectacular. But then far away from that, they look pretty normal. In fact, you see spiral galaxies here.
If you are watching this and haven't already, please like, share, and subscribe.
And beautiful and stunning, and makes you want to worship the Lord. It really does. So in terms of the details,
I agree with
the quantitative details, what did they find? Lots of galaxies at great distances, even beyond redshift 14. They found galaxies redshift 15, redshift 16, 17, some even out to 20. That is way beyond.
So, lots of galaxies at great distances. What is lots? Any kind of number here would be appreciated. And really, what we to talk about in terms of galaxies, in terms of galaxy population, is not the number of galaxies. It's the number density of galaxies, because we're only looking at a small volume of space. And so we aren't counting each individual JWST image is not the entirety of all galaxies. It is simply the number of galaxies within that volume, which on large volumes is isotropic, but that's a story for another time. What I'm getting to is we don't count individual galaxies in this. We talk about galaxy density, and the fact that he's talking about galaxy numbers illustrates to me that he does not study this subject or even look into the subject at all. Now, are there lots of galaxies beyond redshift 14? Now, this is I am showing evidence that I have not put in the proper amount of do your own research. I don't know how many I don't know what the number of galaxies looks like beyond redshift 14. Have we found galaxies beyond that redshift? That I don't doubt. How many? I don't know. Have we found a galaxy out to redshift of 20? Possibly. I think, if memory serves, the large galaxies that are overluminous, thus predicted to be overmass, are around a redshift of around 17 or 18, somewhere, a redshift 17 or 18. Oddly enough, those discoveries make no mention of the fact that the number density of galaxies is too big. They mention that these galaxies are overluminous and they are thus they have too much mass. Actually, they have too much mass because they've looked at it through other mechanisms other than simply a mass luminosity relationship. But they're too massive. Not in no paper that I have read have any of these papers said we have found an overabundance of galaxies in these spaces. So where he's getting this, I don't know. I would have liked to have seen references to this, but he doesn't supply any.
On what the secularists were expecting. I was expecting that, but they weren't. So we got that.
He was expecting it because, of course, it's about him. This is another thing that I find among flat earthers and people of that sort of ilk. It's more about them than it is about the science. It's more about being correct than it is about having a good understanding of the universe itself. Howdy, Dr. Parks. Thank you. I am not exactly feeling well, but I appreciate you saying I'm looking well. So this isn't about. It seems to me that there is a good dose of arrogance. Of, hey, this is what I said it would be like this, and they're wrong. Like, no. This is what the science is saying. This is what the evidence is showing. If your evidence, or if your science, biblical science is saying this, then why does it have anything to do with you? Unless you're the only biblical cosmologist out there, which I know for a fact is not actually true.
That one right.
Why do they think 14 would be the limit?
Because that corresponds to 300 million years after the Big Bang, and the simulations show that galaxies take longer than that to form.
Roughly. I need to check his number of 14. That seems to be too small of a redshift to correspond to 300 million years old. But I'll trust him on that one.
Yep. So, and then the farthest galaxies they found, fully formed, they didn't find baby galaxies. They found they're massive. Some of them are comparable of mass to nearby galaxies and well structured. They found spiral galaxies out those distances. They even found barred spiral galaxies, and those are supposed to.
So this is an example, again, of a flat earth tactic. They will present exceptions as the rule. Have we found massive galaxies? I have already stated that we have. Are they the rule? No. There are a small subsection of massive galaxies a small subsection of galaxies seem to be overly massive. This was a couple of years ago. This was one of the first releases of 13 studied galaxies in this same redshift area. Only 6 of them were overmassive. The other ones had masses that were within predictions. All 13 of them were not well structured. All of them were irregular. Now, in terms of finding a spiral galaxy, I was astonished he was making that claim because I'd heard nothing about that. And so I looked it up, and yes, apparently JWST has discovered a really pretty spiral galaxy. Where is it? Let me see if I can find it. This is actually pretty cool. I have to admit, I'm only in the process of really, there we go. I'm only in the process of investigating this. This is from a Scientific American article. There it is. So you can see this galaxy, which is some 2 billion years after the Big Bang. Now, he has set the number of a redshift of 14, which he then states is 300 million years after the Big Bang. He is then presenting this, which is a galaxy which is presumed to be 2 billion years after the Big Bang. Now, it's still too early for this, from my understanding, but it's not apples to apples. It's disingenuous because you might think he is stating that they found spiral galaxies in or around redshift 14. We haven't, not to my knowledge. And when it comes to, on the whole, when it comes to the population of spiral galaxies in regards to the total population of galaxies, meaning how many spiral galaxies are there in the ensemble, what fraction of galaxies are spirals? That fraction is extremely low in the early universe. Effectively, we've got one, maybe two. I haven't looked too far into it. Dubbed the Big Wheel. It's remarkably young for a galaxy of its grandeur. So I need to read this Nature paper. But, oh, here we go. You clearly see the Big Wheel is a true outlier. So, again, this is indicating that he is suggesting he is taking an exception and putting it forward as the rule. This is a singular object within this population of galaxies thus far. That is not what we see in what we see within the local universe. Within our own galaxy, or within our own local group, which is very local, we see 3 spiral galaxies and about 20 or so dwarf ellipticals and irregulars. When you talk about something that beyond our local group, again, we see lots of spiral galaxies. I can't remember what the exact spiral fraction is, but it's definitely on the order of 20 to 30%, if not larger. The largest population by far is ellipticals that we know of. It might be irregulars simply because we can't see them, because irregular galaxies tend to be smaller galaxies, or at least locally, from my understanding. So yeah, this is disingenuous. He is presenting this as if this is the rule, when it is in fact not. Yeah. And again, this is a flat Earth tactic. Oh, appreciate that. Thank you, Askin. Of misrepresenting what is actually being found.
Supposed to take many billions of years to form. The barred spirals have, they have kind of that central bar, and then they start spiraling. They're beautiful. So they were amazed at the mass of these galaxies. They're comparable in mass to nearby galaxies.
Some of them, again, 6 out of 13, 5 out of 13, something like that. And now there's actually, I might want to do a video on this. There's actually a viable explanation that says these are not galaxies, but black hole suns, which are not black holes. But I only looked at it once, and I've of course completely forgotten what that is. But apparently there is some mechanism that this is actually a stellar object that is exceedingly luminous, kind of like the engine of an active galactic nuclei. I really need to look into that more to say more intelligently on that. But again, it's a possible piece of evidence. But again, this is suggesting that that what we are seeing in the early universe is identical to what we're seeing now. And that's a problem for him, because in fact, and again, a flat Earth, this is common among flat Earth, the citation they use does not actually support their own position. Because as I've said, and again, he hasn't explicitly stated this, but from context clues, I can say that he believes that the universe is the same throughout. You should have the same number density of galaxies. You should have the same galactic fraction. You should have no evolution of galaxies at all. So the early universe and the local universe should look identical. They do not. So therefore, biblical cosmology has a problem. Creationism has a problem. You have to come up with a biblical explanation for why the early universe does not look like the local universe, regardless of what he is trying to tell you, because they simply do not.
But now it's past peer review, and it's going to be published in the Answers Research Journal. This was something that I looked into November, December last year. My speaking schedule was kind of light, so every now and then I get to do some actual research, and it's always fun.
Hold on a second. It says published in a research journal. I'd like to know which one.
So if you're keeping score, the secularists were predicting fewer galaxies at great distances and none beyond redshift 14. That's wrong. We were predicting that many galaxies at great distances exceeding redshift 14, and that's correct. Some out to redshift of 20, based on these, at least the preliminary findings. Secularists were expecting the farthest galaxies would be low mass and clumpy baby galaxies. That's wrong. We predicted that the farthest galaxies would be fully
Some of them are.
mature. That's correct. We were seeing spiral and elliptical galaxies at these distances. The secularists were predicting the farthest galaxies would have only population 3 stars, no heavy elements. That's wrong. We were predicting that they would
do
have
not see that.
heavy elements, population 1 and 2 stars. That's right. James Webb has confirmed that.
I have never seen, again,
it's
I have never
wonderful
seen
success.
evidence of
And,
population 1
2022
stars.
was a very fun year to be a biblical creationist. It really was. Because we got to see these come in and to watch the secularists squirm a little bit. That's always fun. So, well, it is.
Also, from a Christian standpoint, it is fun to watch someone be uncomfortable. I'm pretty sure Christ would have a problem with that. Laugh it
By the
up,
way, something
Buzzball.
else I want to point out too, because sometimes you'll say people, you have people, especially sometimes the flat earthers do this. They'll say, "Oh, NASA's making up all those images, and that's fake. It's all CGI." If NASA was faking all this, why would they constantly produce results that are embarrassing to them? That's what I want to know. Results that confirm biblical creation, right?
Again, not. Yeah. Okay. Not embarrassing.
And by the way, there are a lot of good Christians at NASA. So I got to take a tour of the NASA headquarters there at Houston by 2 astronauts who were Christians. It was very cool. So anyway.
And that means what now? There are Christians in NASA. Good Christians in NASA, whatever that means. Great. No idea what that means to this in the context of this discussion.
New research. There's some new stuff that you haven't heard yet, and you're going to hear it tonight. This will be published. It's already passed peer review. I don't discuss research before it's been peer reviewed, but now it's past peer review, and it's going to be published in the Answers Research Journal.
Answers Research Journal. So one, I'm actually surprised the Answers Research Journal is peer reviewed, but this is yet another piece of evidence that not all peer review is the same. So I'm actually going to look into that. I am actually surprised and happy that that it's peer reviewed, but it's not peer reviewed in, say, APJ, which is the Astrophysical Journal, or ANA, which is Astronomy and Astrophysics. It certainly isn't in Nature. So the fact that it's in Answers in Genesis, or the Answers in Genesis journal, is not overly wow to me.
This was something that I looked into November, December last year. My speaking schedule was kind of light, so every now and then I get to do some actual research, and it's always fun. So what I did is I started looking at studies of the angular sizes of these galaxies that we're seeing in the James Webb Space Telescope images. And this is the paper that will come out in a matter of weeks in the Answers Research Journal. So I'm going to give you a sneak preview of it. And what we've discovered here is really remarkable. It's really remarkable. So as you know, something that is close to you looks bigger.
Oh, all right. So at this point, I'm going to stop this in sake of time. I only wanted to go 2 hours today, but I do want to show a couple of things which illustrate that even you don't actually have to go to extraordinary redshift to contradict biblical cosmology. So this is a write-up within what's known as the NED catalog. I forgot what NED stands for. D is database. E is, I think, extragalactic, and I don't know what N is stand for. So this is a section of, you can't see, there it is. So this is part of it, and you can see the papers that are cited within. So I'm not quoting a paper exactly, I'm quoting something that is hosted on the NED database, which is part of the Infrared Processing and Analysis Center at Caltech. So he claims, so remember, he does not believe in galactic evolution. He explicitly stated that. Notice here, observed evolution of the Hubble sequence. Now, the Hubble sequence is something created by Edwin Hubble, who was first studying galaxies. He came up with something called the tuning fork diagram, which I won't get too heavily into, but effectively he created a schema via which to distinguish various types of elliptical galaxies from various types of spiral galaxies. Irregular galaxies are actually not in the tuning fork diagram. They are separate from that. But what we look at is number density. And so we're looking at, I know you can't read this. Actually, can I zoom in? So it is, here we go. That's a redshift of 3. So we're not looking at a redshift of 14. We're looking at a redshift of 3. So it would be the universe as it was so redshift of 2, the universe is half as old as it was. A universe of redshift of 3, the universe is a third of the age than it currently is. So roughly 4 billion years old or so. And we can see that these are the objects. These are the number of galaxies that were determined or that were found with, that's number fraction of galaxies. Basically, how many galaxies are spiral galaxies? How many galaxies are elliptical galaxies? So elliptical galaxies are in red, spiral galaxies are in blue. And what we see over the span of only, redshift of 3, that the fraction of spiral galaxies goes up and the fraction of elliptical galaxies goes, so as we get to the local era, the number of spiral galaxies goes down and the number of elliptical galaxies goes up. So in the past, there were more spiral galaxies than there were elliptical galaxies, which clearly illustrates that something is happening over time, that there is some sort of evolution over time. You look at this graph, and this is including, what is this? This is, this one down here is number density. So the black line is all, the red line is again, elliptical galaxies. The spiral galaxies are in blue. And what we notice is that the number density actually drops with time, that there are more galaxies now than there were back then, which kind of makes sense. As the universe gets older, more stars are going to form and coalesce into into galaxies. So again, this is blah, blah, blah. What was I saying with this? This is evidence, numerical, quantitative evidence that the universe is actually evolving, or at least the galaxy ratio is evolving with time. And I don't have to go to redshift 14 to show you this. I only need to go to redshift 3. So if he is stating that the early universe should look identical to the present universe, that is not the case. The universe 6 billion years ago does not look like the universe today. The reason for this is galactic cannibalism. The reason for this is, or rather, the best explanation for this is over time, you have more galaxies interacting with other galaxies and eating each other or disrupting each other. And what our simulations have shown is if you take two galaxies, smash them together, and ultimately have one galaxy at the end, that galaxy will be elliptical. It doesn't matter if you start off with two spirals, or a spiral elliptical, or two ellipticals. You smash those two things together, at the back end, you're going to form an elliptical galaxy. And so this is well within our predictions, is that we would predict that spiral galaxy, the number density of spiral galaxies would drop with time, and the number the number density of elliptical galaxies would rise in time. This is contrary to biblical cosmology. Again, more examples of this. This graph also goes to that claim of we would expect to see, or we see a lot of spirals and all that. Again, we expect, based on what we see to redshift 3 and beyond, is that peculiar galaxies, read irregular galaxies, the mass fraction or the number fraction of those would also increase because of the fact that in the early universe you have the tighter space, you have more gravitational distortion. Over time, the universe gets larger, the frequency of these drops, so the number of irregular galaxies that we should find is going to be lower because the merger process has been completed. And so these galaxies have reshaped themselves into elliptical galaxies. Peculiar galaxies are, generally speaking, galaxies that are in the process of merging. I'll give you an example of that. Antenna, I can't spell. There it is. Antenna galaxy, or as I like to call it, the fetus galaxy. What we're seeing here is, and you can kind of, if you squint hard enough, this galaxy, this blob over here, was a spiral galaxy. You can see that there is a nucleus here, and if you squint, you can see that there is some kind of disc-like or spiral structure to this particularly being maybe a spiral arm. But they are greatly distorted. This was actually two galaxies. This is one galaxy that was over here. You can again look at this white area surrounding it, or white area here. And then this white area, it actually kind of looks like a pair of lungs, is that this corresponds to one galaxy, this corresponds to the second galaxy. And these two galaxies are in the process of merging. If you were to look at this further out, and let me see if I can find you a better image of this. There it is. If you zoomed out, what you would see are these tails that are coming out of it. This is why it's called the antenna galaxy. is, and I've also heard this as the mice galaxy. It's that you have these long tails. These are referred to as tidal tails. These are expected from galactic collision simulations. So this is well within prediction of the idea of two galaxies smashing into each other. Once this process is done, these two galaxies will become one complete galaxy, and that galaxy will be elliptical. It will no longer be irregular, it will be elliptical. Potentially these two, while they're one galaxy now, potentially they could become two. They could split again and then spiral into each other or fall into each other and then become one galaxy as a whole. So, yeah. So I wanted to, so again, purpose of this was to, let's see, live stream, there we go. Hopefully I haven't put people to sleep. Where am I? I hate Windows 11. So I'm right about to wrap up here, but I wanted to, again, the purpose of the stream is this notion of using science to prove the Bible or prove that that God exists. It's wrong-headed, and as we saw with Dr. Lisle, he uses a lot of flat Earth tactics. He misrepresents what the current models actually say. The source that he is using to refute the current model actually is highly problematic to his own model. And he is dismissive towards mainstream science, and shows a certain bit of arrogance in terms of doing that. It occurs to me, though, that if I want to be honest about this, that I really need to approach this much more analytically. I have also made kind of just sweeping statements. I've tried to back up my claims, at least in the end, by showing you those plots. But I want to be able to say this is the number of spirals that we have found in the early universe, as opposed to saying we've only found a couple. I want to give you. I would want to actually back that up with citations. So, but anyway. All right. So that's basically all I have now. I do want to, can I do this? Nope, that's not what I want to do. Yes, it is. If you'll bear with me, I have an outro, but I haven't actually done anything with it, or I haven't actually set it up yet. So, and I want to do that. Media source. Sure. Yeah, again, bear with me. I'm here. Google Drive. Screen is black, but I'm still here. Personal. Yes. No. Crud. Hold on. I don't want to use the wrong outro. That's not what I wanted. How about that one? Nope, that's not how I wanted. Oh my god. There we go. What's the most recent outro? That one. Okay. That's not the one I wanted to use, but I'm going to use it anyway. Thank you for watching. I am Professor Parks, PhD, and I am an advocate for advancing astronomy. If you like this sort of thing, please like, share, and subscribe. If you'd like to help me out financially, consider becoming a channel member. If you'd like to help out the observatory financially, please hit me up on PayPal. Peace out, and clear skies.